On to our next lesson. We're going to be finding area of circles instead of finding the circumference. So we're moving on. Now area, reminder, we had a couple little area reviews, but the area is the space inside of a closed shape. All right, so that's all that space in there. And we measure that in square units. There's a specific formula to use. In this key concept here, we have this special formula. Now notice there's not another formula with a D in it. This formula, you can only use R. So if a diameter is given, then you'll have to cut it in half or divide it by 2 so you can use the number in this formula. You have to turn the diameter into a radius by dividing it by 2, or find the radius using the diameter by dividing the diameter by 2. Okay, so you can only plug in radius into there, so make sure you're careful about that and not plugging in diameters into where radiuses can go. All right, so it's just a matter of using a formula. You just have to put in the appropriate numbers and boom, you'll get the answer. All right, so let's look at example 1. Find the area of the circle, and it specifically tells you to use 3.14, so that's important, or else you'll be confused because maybe on a test you'll input an answer and it'll say it's wrong, but you feel like you did everything right, but you press the pi button on your calculator or online, and you should have used 3.14, and you're just a little bit off to make your answer not be recognized by a computer. All right, so important, use the right approximation that they give you. So here we have, you can probably read through this pretty much on your own, but look, the one thing that I will ask you to do when you're doing work at home is always write this formula down. All right, it says area of a circle. So you would go up here and find your area of a circle formula. You'd write that down. Write it down. Don't try to substitute right away. Just write the formula down. Next step, replace the variables that you know with the numbers. All right, so pi here, they said to use 3.14, so plug that in. We find they have given us the radius. We know it's the radius because it goes from the center to the edge of the circle, and we put that in there. Now, we have to remember that order of operations, exponents are done before we do multiplication. So you do the 2 squared first, which means 2 times 2, and that gives us 4. 2 times itself, which is 4, and then multiply it by 3.14. And why did we have to change to this symbol instead of an equal sign? Because we used an approximation for pi, right? We didn't use an exact number for pi, which you can't unless you actually leave the pi symbol in there. Like this, you could write area equals, all right, and you could square the 2 and get 4. And instead of writing 3.14 and multiplying, you would just let the pi symbol chill there. And then you can leave the equal sign there, because now you haven't done anything to approximate. It's 4 pi is the actual answer. 4 pi, in this case, inches. So if it didn't say to use 3.14, and sometimes it'll say like, oh, give the exact answer for this problem, then you don't replace pi with an approximation. You just leave pi in there, and it kind of acts like a variable when we were doing like combining like terms and stuff, like an x. It kind of just acts like that, and you have like a coefficient to that pi, the 4, and that's how you would write the answer. That's an exact answer for this problem, whereas this, you replace pi with 3.14, which is called an approximation for pi. Okay, and then you multiply it and you get an approximate answer, a pretty close answer to what it should be. All right, and then we always have to, oh, I made a mistake. It's not inches. We're not measuring length. We're measuring area. So this should be inches squared, or square inches down here. Okay, so that's 12.56, approximately 12.56 square inches. Okay, now, in this case, they're asking you to use the approximation 22/7, right? 7 goes into 22 about 3 times, which pi is about 3, 3 and a little more. So that's another approximation for pi. It's not as well known as 3.14, but it still works. And in this case, we're using it because 14 plays nicely with 7. All right, and you can look through the work here. Write the formula, right? We're looking for area, so we use the area formula. All right, and then replace pi with whichever approximation you were told to use, or whichever one. Sometimes it's just whichever one makes sense to you. But in this case, they gave you a specific one to use. So you replace pi with that, and then you see that they gave you the radius. Specifically, say they said the radius. So good, because we have a formula that only will accept a radius. So we put the 14 in there, we square it, we get 196, and then I mean, okay, some of you know that 7 goes into 196 nicely, but it's a little bit of a stretch to know that you could simplify that. But anyway, you get 22 times the 28 when you cross simplify with the 7 in the bottom, and then 22 times 28 gives you the answer of 616. Okay, and that's going to be square centimeters. Important that you always put square units, whatever the unit is, because area is measured in squares. All right, the squares that it takes to fill up the enclosed space inside that circle or whatever shape you're talking about. All right, let's stop and reflect here. Cross out the formula that is not used for finding the area. Well, let's see. Of a circle, sorry, of a circle. Well, let's see, which one do you think it is? This one, this one, this one, or this one? All right, I'm gonna say, oh, I see. These two have approximations of pi, so they would give you decent answers. This is the actual formula. Anybody know what this is the formula for? Yeah, that's the formula for the area of a triangle. So that's not the one we want. All right, so that's not going to be used for a circle. All right, A. Find the area of a circle with a radius of 3.2 centimeters, round to the nearest tenth. All right, they didn't tell you which approximation to use, so I would use 3.14, but I'm not going to make you do that, okay? Use 3.14. So I'm going to have you pause, try it yourself, and then check out the answer here when I click this button. All right, hope you did all right. If you need any help, please rewind and try again. Next page. This one, in this case, it's a little bit challenging because they will read it. What do you think is challenging about it? Or what do you think is one extra step? All right, it says find the area of the face of the Virginia quarter with a diameter of 24 millimeters. Did you notice? I tried to warn you. All right, in this case, they gave you diameter, but the area formula only has an R in it. So you need radius. So when we look at this, it's not cooperating. All right, when we look at this diameter here, all the way across this quarter is 24. We don't want that. We want halfway across, so halfway across is going to be 12. All right, 24 divided by 2, or 24 like they did, 24 times a half. All right, half of the diameter, half times 24. All right, so that's 12 millimeters, and then you plug it in. It says use this approximation, 3.14. So boom, put the 12 in, make sure you follow order of operations. 12 squared is 144, times it by 3.14, and there is our approximate answer for this. And what type of units? Area is always measured in square unit. So this is square millimeters in this case. All right, you got one to try on your own. Make sure you write the formula. Substitute in for the variables and for pi, and then follow order of operations to simplify. Pause, try it. All right, time to check. Hopefully you did fine. All right, now we got a semicircle, which is half of, see this word here, half of a circle. So just throw a half in there in front of the pi r squared and you can find the area of a semicircle. All right, here's this example here. We just want, they're telling you to find this area of the blue, which is just half of a circle. We call it a semicircle. Tricky part, ready? Tricky. They give you the diameter. But what are you supposed to plug into this formula? It says radius, R for radius, right? So we have to cut that in half. Now that has nothing to do with the fact that this is a semicircle. That's just the fact that our formula asked for radius and they gave us the diameter. So for this R, we have to realize that it's not 16, it's actually 8. All right? And then if we forget about this half here, the pi r squared, the pi times 8 squared is going to give us the full circle. So we just have to multiply it by half, or in this case, they changed it to 0.5, so it's easier to type in your calculator. Just multiply all those up, and you get approximately 100.5, which in this case, it's going to be square inches, 100.5. All right, you got this, got it to try. Pause, try it, see how you do. They give you the radius, so that's a little bit easier in this case. But make sure you use this formula given up here of area equals 1/2 pi r squared. Good luck. Here's the answer. All right, hopefully you're doing fine here, and we're ready to do some practice. All right, you can read through this. It mentions that it is a semicircle. I won't go through the whole problem, but it's trying to give you an example of a word problem. Semicircle above the free throw line with a radius of 6 feet. Good, they gave you that. Find the area of the semicircle, and it's just following the steps that we've already done. Make sure you label with square units. All right, good luck on your practice today. I hope that you are all safe and well and your families are good. Have a great day.